Hi there guys, it's Mr. Axel here with a reminding of the remainder of the notes for section 5.5 on tangents. Alright, so we're going to pick up right away with the first thing. A circumscribed angle is an angle with sides that are tangent to a circle. So that is a key word for today, or for this lesson or video. Again, an example of a circumscribed angle would be something like angle RSQ. It says an angle with the sides that are tangent to a circle. So if QS is tangent to P, circle P, and RS is tangent to circle P, then this is an example of a circumscribed angle, QSR. Alright, so if that's what a circumscribed angle is, then we have a theorem to go with it. The theorem states if two segments or lines are tangent to a circle, then the circumscribed angle, which is again something like QSR, and the central angle, which is something like QPR, that intersect the arc formed by the points of tangency are supplementary. Alright, so this theorem is simply saying that if you have a circumscribed angle, like the pink angle there, and a central angle, then those two are supplementary. So angle P plus angle S are supplementary, equal to 180. Alright, and again, we can only say that if, again, QS and RS are tangent. And again, just to review, if they're tangent, the radius and the tangent line are perpendicular. Same thing goes over here. If PR is radius and RS is tangent, then we have a perpendicular, meaning that they're 90-degree symbols there. So therefore, then their angle P and angle S are supplementary. Alright, so circumscribed polygons. Circumscribed polygons have vertices outside the circle and sides that are tangent to the circle. Alright, so here we have examples of circumscribed polygons. With circumscribed polygons, we know that the vertices are outside, so all the angles are in the outside of the circle. So just like we have here, all the vertices are in the outside, and then all the sides are tangent. So again, meaning that just touch the circle at one point. Alright, so you need to have that scenario in order for it to be considered circumscribed. Non-circumscribed polygons would be some pictures like this. Again, let's say the middle one, all but one side are tangents. This picture on the right, none of them are tangent. Alright, and then here, they're just overlapping. None of the sides are tangent. Alright, so circumscribed polygons. Alright, example 5. Alright, it says if the measure of angle EGF is 19x plus 9, and the measure of angle D is 10x minus 3, find the measure of angle D. Well, again, just like in theorem 10.13, we can probably take a guess at what the equation is going to be for this, right? They're going to be supplementary because that's what the theorem said, right? But however, we want to understand that before we make that statement, the why behind it, right? And again, the why behind this is they're supplementary because we have the 90-degree symbols at angle F and angle E. They're perpendicular. So if you have that, then we can say that ED and FD are tangent lines. And if they're tangent, then we can say that 19x plus 9 plus 10x minus 3 are supplementary. Alright, if we know that, then we can make this statement. Alright. Alright, so again, you're doing a little algebra to figure out what x is. You got 29x plus 6 equals 180. Algebra to solve for x. $174 divided by 29 is 6, so x equals 6. So that's what x is, but again, we need to find the measure of angle D. So measure of angle D is 10x minus 3. Well, it turned out that x equals 6. So then measure of angle D is 60 minus 3 is 57. Alright, so measure of angle D is 57. Alright, so finally, example 6 to wrap it up. If we know that, or we're given, or we're told that triangle JKL is circumscribed about a circle Q, find the perimeter of triangle JKL. Alright, so again, polygon is circumscribed about the circle, meaning that all the angles are outside of the circle. That checks out, and we know that we have tangent points at M, P, and N. So that is a scenario. Now the angles outside don't really matter. The main thing that matters is what we know about tangent lines. The main thing we know is that if lines are tangent, then some distances are actually going to be congruent. So for example, JM and JP are congruent because lines are tangent. So 14 is JP. And the same thing goes with KM and KN. If the lines are tangent, then we can say that KM is 7. And then same thing goes with LP and LN. If they're tangent, then in this case LN is 11. So we're asked to find the perimeter. Again, add up all the sides. Perimeter equals, we can just multiply those by 2 and then add them together. So we can say something along the lines of 2 times 14 plus 2 times 7 plus 2 times 11. And then that's going to be our perimeter. So the perimeter is going to be 28 plus 14 plus 22. Perimeter is going to be 64. Right. Well, that wraps up the notes for tangent lines. Again, if you have any questions, please contact Ms. Vagarai. Again, don't be afraid. Let us know. Thanks.